In this video we're going to look at a typical question relating to mass defect. Pause the video now and try all parts of the question. So in order to work out the mass defect, we need to first understand why there is a mass defect and which side or which part has a lower mass, which part has a higher mass. So what's crucial to remember is that the mass of the individual parts of the nucleus is greater than the mass of the nucleus. So why is that? Well, we know from Einstein's equation that E equals mc squared, and when we have a whole nucleus together, we need energy to hold it together. So there is some binding energy which holds the nucleus together. If we add up the mass of the nucleus and the binding energy, then we get the mass of the individual parts, obviously converting between energy and mass using this equation. So how do we answer part A? So we're looking at a copper nucleus. So we've been given the nuclear mass of the mass of the nucleus, 62.91367 U. What is the mass of the parts? Well, we've got a proton number of 29, so we've got 29 times the proton number. So the mass of the proton, 1.007276 U, plus the number of neutrons. So that is, we're going to be 34 neutrons times the mass of the neutron, so 1.008665 U. Now we don't need to take into account the electron because it is very much the nucleus. If it was the atom, that would be different, but it's the nucleus, so that is all we need. So what is that going to equal? So we can always type that into our calculator. So that equals 0.591944 U. Now you'll notice that I am leaving it to 6 significant figures, which is important because we are given our information sig fig, and these masses only differ, a very, very small amount. Secondly, I'm leaving it in terms of U for now. Now we need to know that U equals the atomic mass unit, which you can look up on your data sheet, 1.661 times 10 to the minus 27 kilograms. So our mass in kilograms is obviously this multiplied, which gives us 9.832 times 10 to the minus 27 kilograms. And I'm going to leave it to 4 sig fig because I've been given my atomic mass unit to 4 sig fig. So what is the binding energy in joules and eV? So we know that E equals mc squared. So the energy is going to be this mass, 9.832 times 10 to the minus 27 kilograms, times by the speed of light squared, which gives us 8.8488 times 10 to the minus 10 joules, or in eV, that is 8.8488 times 10 to the minus 10 divided by 1.6 times 10 to the minus 19 eV. So I'm not going to bother writing that out, but that will give you your answer in eV. And what is the binding energy per nucleon in eV? So how many nucleons are there? Well, it has a nucleon number of 63 because there are 63 protons and neutrons in total. So you take whatever your answer here is and you divide it by 63. So if we call that, whatever it is, you take that, you divide it by 63.